Good morning students, this is Latif sir. In this video today I'll discuss about molecular orbital theory. In the last video I have discussed about valence bond theory, hybridization, okay. So and have told that using hybridization concept, using valence bond theory and hybridization and VSEPR theory, using all this theory you can show the formation of covalent bond, okay. And today I'll discuss about molecular orbital theory for formation of covalent bond. Using molecular orbital theory, you can also explain the formation of covalent bond between two atoms. And this molecular orbital theory is more acceptable and more applicable theory for the formation of covalent bond. Now see the features of molecular orbital theory. You know, when two atoms combine together, their atomic orbital overlaps and therefore you will get molecular orbital. So atomic orbital combine together to form molecular orbital, and the atomic orbital of comparable energies, almost same energies and proper symmetry combine to form molecular orbital. And the number of molecular orbitals formed is equal to the number of atomic orbital that combine. If two atomic orbital combine together, then you will get two molecular orbital, and between these two molecular orbital, one molecular orbital will be bonding molecular orbital, another will be antibonding molecular orbital. And the bonding molecular orbital has lower energy and greater stability than antibonding molecular orbital. That is, bonding molecular orbital has lower energy and antibonding molecular orbital has higher energy. And during writing electronic configuration, okay, or during filling the molecular orbital with electron, you have to follow above principle, Pauli exclusion principle, Hund's rule. So the molecular orbitals are filled with electron in accordance to above principle, Pauli exclusion principle and Hund's rule. You know, according to above principle, you have to fill that molecular orbital from lower. First, you have to give electron in lower energy molecular orbital, then in higher energy molecular orbital. Now see here, it is given the linear combination of atomic orbital to form molecular orbitals takes place only when, that is conditions for formation of molecular orbital. The linear combination of atomic orbital to form molecular orbital takes place only if the combining orbitals must have almost same energy. Already I have told the combining orbitals must have almost same energy or comparable energy, and the combining orbital must have same symmetry, and the combining orbital must overlap to maximum extent. Okay, these are conditions for linear combination of atomic orbital to form molecular orbital. Now see one term related to molecular orbital theory, which is bond order. Bond order. Okay, later I am telling what is bond order. So first see formation of H2 molecule, that is molecular orbital of hydrogen molecule. Okay, formation of hydrogen molecule. In hydrogen molecule there are two hydrogen atoms, and in each hydrogen atom, hydrogen atomic number is 1, so its electronic configuration is 1s1. Now two hydrogen atom combining, so 1s orbital of each hydrogen atom will overlap to give two molecular orbital, and between these two molecular orbital, one molecular orbital is known as sigma bonding molecular orbital, another is known as sigma star, that is antibonding molecular orbital. Sigma 1s means sigma bonding molecular orbital, and sigma star 1s means sigma antibonding molecular orbital. Okay, so when two hydrogen atom combine to form hydrogen molecule, their 1s atomic orbital will overlap to form two molecular orbital, and one is sigma bonding molecular orbital and another is sigma star antibonding molecular orbital. And sigma star, that is antibonding molecular orbital, has much higher energy than bonding molecular orbital. Now see, in each hydrogen atom there are one electron in 1s or atomic orbital. So there are total two electron. There are total two electrons. Okay. So you have to fill this two electron in molecular orbital. So two electron you have to give in sigma bonding molecular orbital. You know each orbital can accommodate maximum two electrons. So there are total two electron in hydrogen molecule. Okay. So you have to give this two electron in sigma bonding molecular orbital. So so the molecular orbital electronic configuration of H2 molecule is sigma 1s2. Okay. And there is no electron in sigma star antibonding molecular orbital of hydrogen molecules. Okay. Similarly for helium, in helium there are total uh, 4 electrons in He2 molecules. Helium means helium molecules means He2 too. So in helium molecule there are total 2 helium atom, and in each helium atom there are 2 electrons. Helium means atomic number 2, so its electronic configuration of helium atom is 1s2. So two helium atom combine together to form helium molecule. So so total 4 electron in helium molecules. In helium He2 molecule, two helium atom combine to form Ha2 molecules. So in each helium atom there are 2 electrons. So total 4 electrons in helium. So the electronic molecular orbital electronic configuration of helium 2 molecules, He2 molecules, that is 2 electron in sigma bonding molecular orbital and 2 electron in sigma star anti-bonding electron in case of He2. Okay, so molecular orbital electronic configuration of helium molecule is sigma 1s2 and sigma star 1s2. Okay, so in helium molecule there are 4 electrons, 2 electron in sigma bonding molecular orbital and another 2 electron in sigma star anti-bonding molecular orbital. Now see the bond order. What is bond order? What is bond order? Bond order is equal to half into number of electron in bonding molecular orbital minus number of electron in anti-bonding molecular orbital. Bond order is equal to half into number of electron in bonding molecular orbital and number of electron in minus number of electron in anti-bonding molecular orbital. Okay, and the bond order may be a whole number or fraction or even zero. Okay, zero bond order means there is no bond, the molecule does not exist. Bond order of a molecule, if the bond order is 0, then the molecule does not exist. Okay, it is insignificance. And if bond order is 1, then in the molecule a single covalent bond is present. If bond order is 2, then double covalent bond is present, and if bond order is 3, then triple covalent bond is present, like this. Okay, and higher the value of bond order, lesser will be the bond length. Okay, that is with bond order and bond length is inversely proportional. So what is the bond order of hydrogen molecule? In hydrogen molecule, 2 electrons in sigma 1s orbital, 2 electrons, and there is no electron in antibonding molecular orbital. So bond order of hydrogen molecule is half into 2 minus 0, that is 1. Bond order of hydrogen molecule is 1. So in hydrogen molecule there is a single covalent bond between two hydrogen atom because its bond order is 1. And in a hydrogen molecule both the electrons are paired. Okay, if all the electrons in a compound in a molecule are paired, then the compound is diamagnetic. So hydrogen is diamagnetic because all the electrons are paired. Okay, similarly helium also He2. In case of He2, the molecular orbital electronic configuration of He2 molecule is sigma 1s2 sigma star 1s2. So 2 electron in bonding molecular orbital and 2 in electrons in anti-bonding molecular orbital in case of He2 molecules. So what is the bond order of He2 molecules? The bond order in He2 molecules is half into 2 minus 2, half into uh, number of electron in bonding or molecular orbital minus number of electron in anti-bonding molecular orbital. So bond order of helium molecule, that is half into 2 minus 2, that is 0. So bond order 0 means the molecules He2 does not exist. I have told that if bond order is 0, then the molecule does not exist. Remember that. So He2 molecule does not exist because its bond order is 0. There is no bond between two helium atoms. So He2 molecule does not exist according to molecular orbital theory. Okay. Now see bond lithium molecular orbital electronic configuration of lithium. In lithium, there are lithium molecule, that is Li2 molecules. Okay, so Li2 molecules in first you have to know what is the electronic configuration of lithium atom. Lithium means 3 electrons, 2 electron in 1s orbital and 1 electron in 2s orbital. Okay, so similar to hydrogen, so in lithium there are total two types of atomic orbitals, 1s and 2s. So at 1s or atomic orbital will overlap, and similarly 2s orbital 2s orbitals will also overlap to form molecular orbital. Okay, so so one is for in case of lithium, two lithium atom, uh, 1s atomic orbital will overlap and 2s orbital will also overlap. Okay, this is 1s, and 1s atomic orbital of two lithium atom will overlap to form, and in each 1s atomic orbital of lithium has 2 electrons. In each 1s orbital of lithium has 2 electrons. Okay, and in each 2s orbital of lithium has 1 electron. Okay, so you can also write like this: 2s orbital 1 electrons. So 2s atomic orbital of 2 lithium atom will overlap to form 2 molecular orbital. Okay, will overlap to form 2 molecular orbital. One is known as sigma 2s, another is sigma star 2s. So in lithium, total 6 electron, 2 electron in sigma 1s atomic orbital, 2 electron in sigma star atomic 1s or atomic orbital, and 2 electron in sigma 2s atomic orbital, and there is no electron in sigma star 2s atomic orbital. So molecular orbital electronic configuration of lithium molecule Li2 molecule is sigma in sigma 1s atomic orbital 2 electron, in sigma star 1s atomic orbital 2 electron, in sigma 2s atomic orbital 2 electrons. Okay, so total 4 electrons in bonding molecular orbital of lithium molecule and 2 electrons in anti-bonding molecular orbital of lithium. So the bond order of lithium is half into 4 minus 2, that is half into 4 minus 2, that is 1. So bond order of lithium molecule is 1. So lithium molecule exists. Okay. And in lithium molecules also all electrons are paired. Okay, similarly see the molecular orbital electronic configuration of oxygen molecules. Oxygen, nitrogens also all are given. In oxygen, 1s and 2s overlap, not 1s overlap of 1s atomic orbital not showing. Okay, it is like this. Overlap of 1s atomic orbital of both oxygen atom, sigma 1s and sigma star 1s. In this picture, overlap of 2s atomic orbital and 2p atomic orbital is showing for oxygen atom. So when two atomic orbital of oxygen overlaps to form oxygen molecule, 1s, 2s, 2p, all these atomic orbital will overlap, and therefore you will get sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, and when p orbitals overlap, then you will get there are total 3 p orbitals. So when uh, 3p orbitals of uh, 3p orbitals of oxygen overlaps with 3p orbitals of another oxygen atom, then you will get 1 sigma bond and 2 pi bond. 1 sigma bond and 2 pi bond. When p orbitals of 3 p orbitals of one oxygen atom or overlaps with 3 p orbitals of another oxygen atom, then you will get total you will get one then you will get total 6 molecular orbital, and among these 6 molecular orbital, one will be sigma bonding molecular orbital, one will be sigma star antibonding molecular orbital, two will be pi bonding molecular orbital, and two will be pi star molecular orbital. Okay, so this arrangement is the molecular orbital electronic configuration of oxygen. Okay, and this is for nitrogens. In oxygen molecule, you can see the sigma 2pz molecular orbital energy of sigma 2pz molecular orbital is lower than energy of pi 2px and pi 2py molecular orbital. But in case of nitrogen, up to nitrogen, the energy of pi 2px and pi 2py molecular orbital is lower than when energy of sigma 2pz molecular orbital. This is the difference between molecular orbital electronic configuration of oxygen and nitrogen. Okay, oxygen fluorine, for oxygen fluorine and neon, this type of arrangement you have to draw. Okay, molecular orbital electronic configuration, and for up to nitrogen, this arrangement. Okay, so electronic configuration, molecular orbital electronic configuration of oxygen is given. The molecular orbital electronic configuration of oxygen is sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2 sigma 2pz2 pi 2px 2 pi 2px2 pi 2py2 and pi star 2px2 pi star 2py2. This is the molecular orbital electronic configuration of oxygen. Okay, again I am telling sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2 sigma 2pz2 sigma pi 2px2 pi 2py2 pi star 2px1 pi star 2py1. This is the molecular orbital electronic configuration of oxygen. Okay, so bond order of oxygen is half into number of electron in bonding molecular orbital, that is 8, minus number of electron in antibonding molecular orbital, that is 4. So half into 8 minus 4, that is 2. So in oxygen molecule there are double bond between two oxygen atom. Similarly in case of nitrogen, there bond order of nitrogen molecule is 3. So uh, so there are triple covalent bond is present between two nitrogen atom in nitrogen molecule. Okay, you have to practice all these molecular orbital electronic configuration of oxygen, nitrogen, and N2 plus, O2 minus, all these electronic configuration, all these diagram are given in your book. Okay, and last topic of this chapter is hydrogen bonding. What is hydrogen bonding? When highly electronegative element like nitrogen, oxygen and fluorine, only these three elements, when attached to hydrogen atom to form covalent bond, the electrons of the covalent bond are shifted towards more electronegative atom. For example, when fluorine is attached to hydrogen, then you will see that the electrons will shifted to more electronegative fluorine atom. Therefore, a negative charge develops on fluorine atom and positive charge on hydrogen atom. Okay, when hydrogen is attached with more electronegative element such as fluorine, oxygen, and nitrogen, then the molecule will be converted into two pole. One is positive pole, another is negative pole, and then this molecule, this HF molecule will be attracted by another HF molecules, and this force of attraction is known as hydrogen bonding. Okay, hydrogen bonds are generally showing by giving three dots or three dash. Okay, this is hydrogen bond. Okay, so when highly electronegative element like nitrogen, oxygen, fluorine are attached to hydrogen to form covalent bond, the electrons of covalent bond are shifted towards the more electronegative atom, and thus partial positive charge develops. Partial positive charge develop on hydrogen atom, which forms a bond with other electronegative element. You can see these hydrogen atoms forms a hydrogen bond with electronegative fluorine of another molecules, and this is hydrogen bond, weak force of attraction. Okay, so this bond is known as hydrogen bond, and it is weaker than covalent bond. For example, in HF, in water, in ammonia, all this compound hydrogen bond is found. Okay, here it is showing formation of hydrogen bond in HF molecules. Okay, it is showing by giving 3 dot hydrogen bond between two HF molecule. It is showing types of hydrogen bond, two types: intermolecular hydrogen bond and intramolecular hydrogen bond. Intermolecular means it is formed between two different molecules of same or different compounds. For example, in HF, you can see this is one HF molecule, this is another HF molecule, this is another HF molecule. So hydrogen bond is formed between two similar compound, huh, between different molecules but similar compound. Then this type of hydrogen bond is known as intermolecular hydrogen bond. So in HF, in water, in ammonia, in all this compound, intermolecular hydrogen bonding are found. And intramolecular means within same molecule. This type of hydrogen in this type, hydrogen atom is in between the two highly electronegative atoms present within same molecule. Hydrogen bond within same molecule is known as intramolecular hydrogen bond. You can see in orthonitrophenol, this is orthonitrophenol, a hydrogen bond is showing between the OH group and NO2 group. Okay, this is the hydrogen bond, and this within same molecule, so it is intramolecular hydrogen bond. Okay, and due to presence of hydrogen bond, boiling point of compound and volatile, uh, the compound will become less volatile. Okay, all this property you can explain using the concept of hydrogen bond. Okay, and this chapter is completed. Thank you, students.